Hey everyone, welcome to today's screen recording for MTRW. Today we'll be talking about multiplying rational numbers. So remember, rationals just means numbers that can be written as a over b, where a and b are integers. Integers are all the whole numbers, negative whole numbers, and zero. So we're really familiar with multiplying rational numbers when there are no signs involved. So for instance, we're familiar with things like, 1/2 times 1/3. We know how to multiply fractions. That's 1/6. Okay, but the difficulty is in dealing with the signs. So let's do signs. And let's say we want the sign of a times b. Okay, so I'm going to draw out a table. I'm going to let rows correspond to the sign of a and columns correspond to the sign of b. So a could be positive or negative. And similarly, b could also be positive or negative. And when you multiply two positive numbers, this is what we're really used to. We do positive times positive multiplication all the time, and that's how we start learning multiplication. So we know that when we take two positive numbers and multiply them, we still get a positive number at the end. However, if we take a positive number and a negative number and multiply them, we actually end up with a negative number. Same if a is negative and b is positive instead. And lastly, if we take two negative numbers and multiply them, we actually get a positive. So one sort of picture way of seeing this is that, let's go back to our favorite, the number line. Let's say I have a positive number y, and I have a negative number. Well, I consider the opposite of y, which is going to be negative. Every time we multiply, multiplying by a negative number, it means we flip the side of the number line that it's on. So for instance, if we start with a positive number and multiply it with a negative number, we should get a negative number. We flip over to the other side. Similarly, if we start with a negative number and we multiply it to a negative number, we flip over to the positive side, which is why negative times negative ends up being positive. If we multiply by a positive number, we just maintain the same side. So if we have a negative number and multiply by a positive, we stay negative. Another thing to observe is we can pull out -1. So let's say if you're comfortable with multiplying things by -1, so -1 times anything, x, will just be minus x. Or let's see, more concretely, we know that -1 times 1 is equal to -1. And we also know that -1 times -1 is equal to 1. So for instance, if we have something like -6 times -8, we can rewrite it instead as -1 times 6 times -1 times 8. And because with multiplication you can move the terms around, we'll talk about this a bit more. We can rewrite it as -1 times -1 times 6 times 8. And these two together equal 1, and we end up with a positive 48. So this is another way to see that minus times minus is positive. Cool. Let's just do some more examples, just to really lock it in. Let's do a straightforward one first. Let's say we have -5 times 4. Well, In this case, we can think of 5 as A, and we can think of 4 as B. A is negative, B is positive, so our answer will be negative. We'll get minus 20. So the way we deal with the numbers, I forgot to mention, is that we pretend the signs aren't there first, and we're just going to multiply the numbers. We can also, like, this doesn't change when we introduce fractions. So let's say I have 1/2 times minus 1/4. So again, I'm going to first deal with the actual numbers part. Let me rewrite that. And then I'll deal with the sign. So numbers wise, 1/2 times 1/4 is 1/8. But because exactly one of the factors here has a minus, our answer also has to have a minus. All right, let's do a little bit more involved example. Let's do -1 times 2 times -3 times -1. Okay, so we had a volunteer help us with this in class. These two together will make -2. These two together will make 3. You're actually secretly using the associative property of multiplication here, believe it or not. Now with these two together, we'll get -6. So this whole thing is -6. I asked this in follow-up question, what happens when, I'm going to just stick on another minus sign in front of the 2. What happens to my answer now? Well, we're going to multiply our previous answer by a -1, right? So that ends up being 6. We notice that here there are 3 minus signs. And here there are 4 minus signs. And this lets us sort of, if we work through more examples like this with multiple factors, we can see a pattern starting to emerge. So as a general rule, I want to make this green. If you have an odd number of minus signs in your factors, so then the answer will have a minus sign. And if you have an even number of minus signs, then the answer will be positive. Okay, so just to summarize, multiplying rationals, dealing with the numerical parts, the number parts of each factor, we deal with that the same way as we always know. We multiply the numbers together. But then, in order to decide what sign we want to add on, we have to look at the signs of the factors and see if the signs of the factors match or not match. So this whole diagram here. And when you have multiple factors, you can count how many negative signs there are, and based on whether or not that number is odd or even, that'll also tell you if the answer will be positive or negative. So now we're going to move on so actually I forgot to write, this comes from lesson 159. So next we'll talk about lesson 161, write that in the corner again, or 160, sorry. And here we're talking about properties of multiplication. We're going to go over 3 properties and examples of why each one is useful, when each one is useful. So the first one is the associative property of multiplication. We've seen the associative property of addition before. It looks really similar though. We're going to take, let's say we have three numbers that we're adding up, multiplying together, a times b times c. And usually if we're doing multiplication, we go left to right. So in other words, we do a times b first, and then we multiply whatever we got here to c. The associative property tells us, hey, we can instead multiply b and c together first, and then multiply this product by a. Seems pretty straightforward, right? Turns out it's actually really powerful, and we can use this to make a lot of our multiplications easier. If we make our multiplications easier, then we're less error prone, or we're less likely to make mistakes. And any kind of tool that'll help us make mistakes less is a good tool. Let's consider this example, 4 times 0.2 times 5. Okay, so if I were to go from left to right, I would first do, 4 times 0.2 is 0.8, multiply it by 5, then I'll get, I do 40, but I add the decimal point, it's 4. On the other hand, I can try to use my associative property. I get 4 times 0.2 times 5, and the associative property tells me, hey, I can do these two first. Multiply these two first. Well, the product of these two is just 1. So I have 4 times 1, which is 4. Way easier than 0.8 times 5. I guess even though 0.8 times 5 is not super hard anyways, if we had more complicated numbers, I would much rather do a calculation like this and get some easy factors out of the way than to deal with products like this. Next, we're going to talk about the commutative property. Commuting, that means you're moving around. That's the easiest way to remember. Like if your parents go commute, right? They drive to work, or they maybe walk or bike to work, or take the train or bus. It's all about moving. So it tells you if I have a times b, it's the same thing as doing b times a. We can switch the factors around. So we can go, left to right this way or left to right this way. I mean, in this example, it looks like it's not doing much, but let's see a more complicated one. So let's use our same example from before. I'm going to do 0.2 times 4 times 5 now. And as we saw from the previous example, it'd be really nice to group the 0.2 and the 5 together, because the two of these multiply together to 1. I'm just going to mark that like we want to group these. So to do that, we can actually switch the first two terms. So we can commute these. And we'll get 4 times 0.2 times 5. And now we can use our associative property again. This is 1. We have 4 times 1. Life is good. So here we're actually using the associative again. The last property is one that we're familiar with. We've talked about it with addition as well, because it involves both multiplication and addition. It's the distributive property. So it tells us that if we have some number a that's multiplied to a sum, I'll write it as b plus c plus d, I can take the factor of a and pretty much just give it to every term in the sum. So I give 1 to b, I give 1 to c, and I give 1 to d. And I think the distributive property is honestly more powerful when it's used the other way. If you see a bunch of terms added together and they all share some factor in common, we can pull that out and then do the sum first. So let's see an example of this. Let's say we have minus 7 times 0.2 plus minus 7 times 1.5 plus minus 7 times 0.3. Okay, so I look over and I have 3 terms. If I were to do PEMDAS, I would have to do these multiplications first. I had to multiply these crazy numbers by 7. And we can notice instead that every term has a minus 7 factor. So why don't we just pull those minus 7s out? So we're going to pull out our minus 7. And what's left over? Well, we look at each term and see what's left over after we take out the minus 7. We're going to get 0.2 here plus 1.5 plus 0.3. Okay, I'm much happier just adding these numbers than doing all these multiplications and then adding possibly even uglier numbers. So now I'm going to add everything inside here. This actually just becomes 2. So minus 7 times 2, that's easy. We know how to do that. Minus 14. There we go. Okay, so just to sum up, we're looking at 3 properties of multiplication. I guess the distributive one is shared between multiplication and addition. And we showed a couple of ways where we can use them to make our lives easier when multiplying and hopefully make fewer mistakes. Okay, the next part we're going to look at exercise number 3 in lesson 160. See some more examples of this in action. So if you're following along at home and you're trying to catch up on this week's MTRW, now would be a good time to pause the video and try parts C and F for yourself. And then we can compare answers when you resume the video. Okay, so I'm just going to write down the 2 questions. Great. So for this first question, I'm going to notice right away I don't like this number 327, but 4 and 2.5 go great together. 4, well, let's not deal with the signs just yet, but if we just consider 4 and the number 2.5, those 2 multiply together to 10. 10 is a great number to have around if we're doing multiplication. So I want to somehow get these 2 next to each other. So one way I'm going to do this is I'm going to commute these 2. And I'm going to get minus 2.5 times minus 4 times 327. So here I use the commutative property. And now that I've commuted these 2, I don't even need to use the associative property if we're going left to right. I can just multiply these 2 first. We have 2 negative numbers. The outcome will be positive. These 2 together make positive 10. Times 327. Now we're going to get 3,270. Easy. Next, let's take a look at F. So the first thing I see is that there's an addition involved. It's not one of those pure multiplication problems like C. But we do have multiplication as well. So if we see kind of a combination of multiplication and addition, we should at least try the distributive property. So now I'm going to look more closely at my terms. So here I have a minus 10. I have the 17.4. That's kind of nasty. But I like the minus 10 quite a bit. And here is another minus 10. Bingo. We have 2 common factors, and we can pull out the minus 10. So now what's left over? Well, in this term, when we get rid of the minus 10, we just have the 17.4. And in this term, after we pull out the minus 10, we just have the 2.6. So I'm going to write a 17.4 plus 2.6. And now I can do the inside of the parentheses operation first. This actually gives us 20. Minus 10 times 20, that's easy. Minus 200. There we go. These are 2 examples where the properties really came in handy for us. I'm just going to make a note that this is the distributive property. Cool. So I'm just going to zoom out of here for a second. Can recap the properties. Cool. And the very last part of this lesson, we went over this worksheet. So this worksheet is not part of the textbook material, but it is, it's kind of extra, but it's not too bad. It's going to help us give some intuition about negative numbers and how they affect inequalities. So not equations, but inequalities that look like this, x greater than 3. Okay, so if you're following along at home, now is also a good time to maybe pause the screen and think about questions 1 through 5. So actually in today's class, we only got to go over questions 1 through 3. So I'll only talk about these 3 in today's video. Let me change my colors real quick. Okay, so the first question says to draw a number line. I'll do that. I'll stick 0 here. If x is greater than 3, mark 3 possible values of x on your number line. Great. So I have 3 here, and I just want to pick numbers that are greater than 3. So really, I can pick anything on that number line to the right of 3, but I can't include the number 3. So I can use a curly brace to indicate, hey, I can include something as small as, 3.0001, but I can't include 3 itself. So I'll pick 2 more values here. I'll pick 4, I'll write it on the bottom, and I'll pick a Google, 10 to the 100. Okay, so simple enough. We're good here. Now let's look at question 2. So we want to multiply each value that you chose by 2 and plot the new values on the number line. Okay, so before I go on, I'll just do that really quickly. So again, I have my number line. Ooh, no, that's no good. Okay, and I chose 3 values. So I chose 3.0001, 4, and a Google. So 3.0001, when I double it, I get 6.0002. 4, when I double it, I'll get 8. And a Google, when I double it, I'll get 2 times 10 to the 100. Obviously, my drawing is not to scale, but good enough. Okay, so the questions are saying, what are some similarities and differences between the 2 number lines you drew? Okay, well, one similarity is actually the order of the numbers stays the same. So, the number corresponding to 3.0001 is still the most to the left on the number line. The number corresponding to a Google is still the most to the right. So, the order of the 3 numbers, when I multiply them by 2, like the 3 markers, has not changed. I also noticed that, initially we had a small distance between 3.001 and 4. We have a really big distance between 4 and a Google. We still have a relatively small distance between 6 and 8, but we still have a really big distance between 8 and 2 times a Google. So we can think of this as we're stretching out the number line a little bit. And the last question, so I guess that is kind of a similarity and a difference. It looks, the 2 lines look a lot the same, but one is stretched out. The last question is asking, okay, are all of your new points still above a certain number or below a certain number? Well, let's answer this one first. I don't think any of them will end up below a certain number because I could have picked a number as big as I wanted in problem 1, and I would get an even bigger number in problem 2. However, I can't pick numbers to the left of 3 in number 1. I can pick numbers that get really, really close to 3, but I can never get to 3. So it turns out that in question 2, we can get really close to 6, but we're also never going to touch 6. If we got something below 6, that would correspond to something below 3 in question 1. Okay, so to finish up this question, all points are above 6. So now let's write an inequality that describes 2x. Well, so first, the inequality that described x is greater than 3. So this tells us 2x has to be greater than 6. we see a lot of similarities between how we deal with equations and how we deal with inequalities. It's not completely the same.